Earth and near-Earth space is a big, complicated, time-varying system. Tracers is one of the sort of early demonstrations of how you can use multi-spacecraft technology to get a picture of how things are changing, how things are moving, how things are evolving.
So not only will it get a global picture of reconnection in the magnetosphere, but it's also going to be able to statistically study how reconnection depends on the state of the solar wind. This is going to really help us understand how to predict space weather in the magnetosphere.
Such a fun mission to be launching today. And while we wait for that clock to tick closer to T0, let's learn a bit more about our launch vehicle. There's Falcon 9 on your screen, a two-stage rocket that is 229 feet tall and getting ready for liftoff in just under 10 minutes from now. Now at launch, it produces more than 1.7 million pounds of thrust. That bottom section of the vehicle, the first stage, or the booster, is powered by 9 Merlin engines. They'll burn for the first couple minutes, carrying Falcon 9 through the thickest layers of Earth's atmosphere. And if you've ever watched a launch in person, you'll know the vehicle doesn't go straight up. Early in flight, Falcon 9 performs a gravity turn, which is a smooth pitch maneuver that tilts the rocket sideways to build up horizontal velocity. And you may hear that called out over the nets as the vehicle pitching downrange.
Now, once the first stage completes its portion of the mission, it shuts down and separates. A stage rocket like Falcon 9 sheds the booster to eliminate the weight and uncover the Merlin vacuum engine on stage 2. To reach orbit, the vehicle needs to go fast, hitting an orbital velocity of about 28,000 kilometers per hour just to keep from falling back to Earth. That's fast enough to lap the Earth in about 90 minutes or fly from New York to here in Los Angeles in under 10 minutes, about 7 times faster than the fastest airplane. Now, after stage separation, today's booster will be landing back at Vandenberg Space Force Base at Landing Zone 4, and this particular booster is returning to Earth for its 16th time. Now, the second stage will take over from there, powered by a single Merlin vacuum engine known as the MVAC. With its extended nozzle and optimized design, the MVAC drives maximum performance in the vacuum of space. Today, we'll ignite that engine 4 times before deploying the final payload into orbit.
And topping off the rocket stack is the payload fairing, a 17-foot wide carbon composite shell that protects the satellite during the uphill trip through the atmosphere. Now, about 3 minutes into flight, both halves of the fairing will separate and parachute back to Earth. And if recovery goes to plan, the fairings will be pulled from the ocean and prepped to fly again on future missions. Now, so much of what makes Falcon 9 remarkable happens in flight. Stages separating, the first stage landing itself on land or on a drone ship in the middle of the ocean, fairings parachuting back, all ready for another flight to space. Every part of Falcon 9 is part of a larger design that comes together to do one thing, escape gravity. And that is the first step in building our multi-planetary future.
Absolutely. Now, at the T-7 minute and 30-second mark, the launch vehicle and spacecraft are in good health and ready for launch. The Falcon 9 team reported on console at T-2 hours and 15 minutes to begin their final checks of the launch vehicle and ground systems. Final checkout of the flight termination system was performed at the T-1 hour and 45-minute mark, and then the chief engineer conducted a technical readiness poll just prior to the T-1 hour point. The Falcon 9 team completed data review of the first and second stage propellant checkouts, as well as avionics and guidance, navigation, and control, also at that T-1 hour mark. There were no issues to report at the technical readiness poll. So most recently, the team completed the poll at T-38 minutes to proceed with propellant load and ultimately launch.
Now, the SpaceX team at Vandenberg Space Force Base began loading propellant on time at T-35 minutes when the launch auto sequence began. And we're loading 2 propellants on the Falcon 9, both a fuel and an oxidizer. For Falcon 9, our fuel is a refined form of kerosene known as RP1. And to burn that fuel, we need a source of oxygen called the oxidizer. Now, most burning on Earth uses oxygen, which makes up about 21% of the air you breathe. However, in space, there is no atmosphere to provide oxygen or other oxygen-bearing molecules, so rockets need to carry their own. And Falcon 9's oxidizer is super chilled liquid oxygen, called densified LOX. Now, the liquid oxygen is chilled well below its boiling point to increase its density, allowing us to load more into the first and second stage LOX tanks. Now, currently fuel loading is complete on the second stage and continuing on the first stage until about the T-6 minute mark when it'll finish up. Liquid oxygen is also loading onto both the first and second stages right now. Now at liftoff, Falcon 9's 2 stages will combine to hold over 1.1 million pounds of propellant.
We started the day with a 0% probability of violating launch weather constraints, and right now we are still experiencing favorable launch conditions. So with that, the launch vehicle, spacecraft, weather, and range are all good to go for a 11:13 a.m. Pacific time launch from Space Launch Complex 4E at Vandenberg Space Force Base in California.
Now, next up in the countdown, the transporter erector, or TE, will be
pressing, self-pressurizing for strong base retract.
Next up in the countdown, the transporter erector, or TE, will begin to retract away from Falcon 9, and that's the large truss structure you see standing next to the rocket. It's hinged at the base and connected to the launch mount beneath the first stage.
Now, during this sequence, you'll first see the clamps around the second stage begin to open up in just about 15 seconds. Following that, the TE will pivot backwards once the clamps are clear of that second stage and slowly swing away from the rocket. It will reach full recline by about the T-3 minute 40 second mark. Now, you may also hear this structure referred to as the strong back as well as the TE, and these are the same structure, just a different name.
And the TE does a lot more than just lean. It rolls Falcon 9 out to the pad, raises it vertical, and stays connected through the final seconds. It also provides fuel, power, telemetry, and command connections between ground systems and the rocket. And you can just make out the strong back reclining away from the Falcon 9 rocket on the pad.
Now, the clamps you saw at the top there help stabilize the second stage during fueling, and they also prevent movement in high wind conditions. Once they open, the rocket is fully free at the top. Right now, both stages are nearly fully loaded with about 1 million pounds of liquid propellant, and that includes RP1, highly refined kerosene, and liquid oxygen chilled to over 300 degrees below 0 Fahrenheit.
Now, propellant is loaded late in the countdown, and that's fully intentional. Colder propellants are denser, and denser propellants mean more performance out of the same tanks. The colder it is, the more mass you can move. Now, before any of that propellant flows, though...
Stage 1 LOX load is complete.
And good call out there. Before any of that propellant flows, the plumbing and engines are chilled down, and that prevents thermal shock and boil-off when the ultra-cold liquid starts moving. And you may hear that referred to as engine chill.
So propellant loading will wrap up in 2 steps. That first stage finishes around the T-3 minute mark, and the second stage will be finishing about a minute later, coming up shortly. You've probably noticed at this point the white clouds venting from the rocket, and that's condensation. As the liquid oxygen warms up slightly inside of the tanks, some of it boils off from liquid into gas. Now that gas is vented overboard to maintain pressure in the tanks. When the vented oxygen hits the warmer outside air, it instantly condenses into these cloud formations that we can observe. This is the same principle as seeing your breath on a cold morning, just on a much bigger scale.
Now, the tanks are also pressurized using helium, and that helium is chilled too, so it stays compatible with the cryogenic plumbing. Now, during flight, that pressurization helps force propellant into the engines as the tanks empty. Now, at the T-60 second mark, Falcon 9 will enter startup, and at that point, the rocket's onboard flight computers will have taken over. And from there on out, the countdown will be fully autonomous.
Just inside of T-2 seconds, the 9 Merlin 1D engines...
Stage 2 LOX load is complete.
There's that confirmation that Stage 2 LOX load is complete. Now, once the 9 Merlin 1D engines ignite and are at full power, Falcon 9 will lift off the pad and begin its climb to orbit. As of
Gas launch closeout has started.
Now, as of right now, the satellite remains healthy and the rocket is tracking no issues. Weather is green and the range is clear to support our scheduled liftoff at 11:13 a.m. Pacific time. With that, Falcon 9 is fully fueled and in startup heading into the final seconds before launch.
Now, coming up in just a few moments, we should hear a call out that Falcon 9 is in startup, and as I mentioned, that is when the rocket's onboard flight computers will have taken over the count.
Falcon 9 is in startup.
And there's that call out for startup. And in just a few moments, we'll hear the final go, no-go from our launch director, or LD, for today's mission.
This is LD on countdown 1. Hold, hold, hold.
Launch abort is running.
This is the LD on countdown 1. We have aborted launch for the day due to airspace concerns. We are proceeding into nominal offload operations.
Now, as you heard, we are standing down from today's launch attempt due to range readiness. Now, the vehicle and payload remain in good health, and our next launch opportunity will be tomorrow, July 23rd at 11:13 a.m. Pacific Time. And for continued updates on all of our missions, follow @SpaceX on X and spacex.com/launches. As always, thanks for watching, and we hope to see everyone back here for our next attempt.
Dark we rise and soar, guided by the dreams we wore. From the oceans to the skies, endless fire burns in our eyes. Beyond the stars we chase the light, with fearless hearts through endless nights. No frontier can hold us down, the universe is our playground. Mountains high and oceans deep, secrets in the void we keep. Every step a tale to weave, for those who dare, who still believe. Beyond the stars we chase the light, with fearless hearts through endless night. No frontier can hold us down, the universe is our playground. Is our playground. Mountains high and oceans deep, secrets in the void we keep. Every step a tale to weave, for those who dare, who still believe. Beyond the stars we chase the light, with fearless hearts through endless night. No frontier can hold us down, the universe is our playground. Echoes call from far away, guiding ships through cosmic sway. With every launch a new sunrise, the quest for knowledge never dies. Beyond the stars we claim the skies, bound by hope that never dies. To worlds unknown we'll make our mark, lighting flames within the dark.
3, 2, 1.